Okay, so the second of the GCSE to A-level transition videos is all about surds. So the first one, what we're going to do is we're going to simplify the square root of 50. Now, the whole thing with simplifying surds is that we can't simplify a surd like 3 times by the square root of 5 because one of them's a square root. I mean, surds just mean square roots. So one of them is a surd, one of them is a square root, and one of them isn't. So with this one, we'd have to write that as 3 root 5. If, however, we had the square root of 3 times the square root of 5, we can say that's the square root of 15. We can multiply these two numbers together because both of them are square roots. So here we've got to do the opposite for the square root of 50. We've got to find two things that multiply together to make 50. Now I could do 5 and 10, but we're not going to, because the whole thing with surds is that you've got to try and find one of these numbers that you can actually do the square root of. So in terms of 50, we can say the square root of 25 times by the square root of 2. Now the reason that we do that is because we can do the square root of 25. So that's going to be 5 root 2, because the square root of 25 is 5. So if we simplify root 50, it's going to be 5 root 2. So that would be a basic version of that question. So let's see about how we can make them a little bit trickier. Let's do the square root of 147 minus 2 root 12. And we've got to somehow simplify this. Now it looks crazy hard, but it's not. So we've got to try and find a number that goes into 147. Now bear in mind, we've got to be able to do the square root of that number. So I could do the square root of 4. I could do the square root of 9. So the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, etc. Now, I know that 49 goes into this one, so I could say that's going to be the square root of 49 times by the square root of 3. So the square root of 49 is 7. So I can simplify this one as 7 root 3. I'm going to minus 2 root 12. Now I can split root 12 down into root 4 times root 3. Now the reason I do root 4 and root 3 and not root 2 and root 6 is I can do the square root of 4. The square root of 4 is 2. So that's 2 times 2 times the square root of 3. Well, 2 times 2 is 4. So we can say that this thing here, or this thing here, is 4 root 3. And then we can simplify that. So 7 root 3's, take away 4 root 3's, leaves us with 3 root 3. So that's how you do that one. Okay, let's have a look at the next example. Okay, so you need to have done the first video in order to do this one. So we're going to expand and simplify square root of 7 plus the square root of 2 times by the square root of 7 minus the square root of 2. Okay, so if we do this, we're going to do square root of 7 times the square root of 7. Now, like we said before, because they're both square roots, that means you can multiply the numbers. So 7 times 7 is 49. So that gives us the square root of 49. And then if we do this, in fact, let me stick on this point. So square root of 7 times square root of 7 gives us square root of 49. And we know the square root of 49 is 7. So that point is, whenever you do the square root of a number times by itself, in essence what we're doing is squaring it. Square root of 7 times square root of 7 is the square root of 7 squared. Square root and squared are inverse, so they cancel each other out, so we're just left with 7. If we do the right eyebrow, I've got positive root 2 times minus root 2. So positive times a negative is going to be a negative. Root 2 times root 2 is root 4, which is 2. Again, which goes back to what we were saying a second ago. That's minus 2. Because square root of 2 times the square root of 2 is just going to be 2. Okay, the next one, I've got the square root of 2 times by the square root of 7. That's going to be plus the square root of 14. We can't cancel that one down, so we leave it like that. If we have a look at the mouth, if we do the smiley face method here, the square root of 7 times by the square root of 2, but it's a negative time. So So it's going to be square root of 14, take away the square root of 14. That just cancels out. So what we're left with is 7 minus 2, which equals 5. So sometimes something that looks incredibly complicated goes down to something which isn't very complicated at all. Okay, so that's that example, example 3. We've got quite a few examples on this one, so stick with it. Okay, the next one is what we call rationalising. Now, rationalising is where we've got a square root on the bottom of a fraction. So if we've got that, 1 over square root of 3. So it's considered bad form in maths if we've got a square root on the bottom, so we're going to times the top and the bottom by the square root of 3. Because just like in maths, if I've got 3/5, that's the same as 6/10, because I've times the top by 2 and I've times the bottom by 2. So as long as you times the top and the bottom by the same thing, it doesn't alter the fraction, it's still the same fraction. So with that in mind, and also what we've already learnt, if I times the top and the bottom by the square root of 3, the square root of 3 times the square root of 3 is 9, or it's the square root of 9, which equals 3. Or the square root of 3 times the square root of 3 will just be equal 3. Then 1 times the square root of 3 is just 1 root 3, which is just root 3. So the way to rationalise this one is you times the top and bottom by the square root of 3. So we get root 3 over 3. I'm going to go through a couple of different methods for this one. So we've got to simplify and rationalise. Square root of 2 divided by the square root of 12. So if we use the method that we just used a second ago, I'm going to times the top and the bottom by the square root of 12. So the square root of 2 times the square root of 12 is going to be the square root of 24. The square root of 12 times the square root of 12 is the square root of 144, or just 12. The square root of 24 over 12. However, this isn't as simple as it can get, because we can simplify the square root of 24. So I know the square root of 24, I can say, if I write that out again, square root of 24 over 12. Square root of 4 times the square root of 6. Square root of 4 times the square root of 6 is the square root of 24. Now, why did I choose those numbers? Well, it's because I can do the square root of 4. So the square root of 4 is 2. So it's going to be 2 root 6 over 12. And now we can try and simplify this fraction. Now we can't simplify root 6 over 12 because this one's the square root and this one isn't. However, if I cover this up, 2 over 12 simplifies down to 1 over 6. So we can have that one as 1 root 6 over 6. And obviously if you times anything by 1, you don't need to put that 1 there. So square root is 6 over 6. So that's one way to do it. And that's by multiplying the bottom by that square root again. Now there's another way to do this. And we're going to end up with the square root of 6 over 6 as well, so I'll leave that down there. Just like before, when we're multiplying two numbers that they've got to both be square roots, here I'm dividing two numbers and they're both square roots. So I can actually say that's the square root of 2 over 12, which equals the square root of 1 over 6. Or square root of 1 over the square root of 6. Right, square root of 1 is just 1. So I can say that's 1 over root 6. And what I've done there is I've actually simplified those. So I've done the cancelling out already. And then I can just times top and bottom by root 6. So times top by root 6 times the bottom by root 6. What do I get if I do 1 times root 6? Root 6. What do I get if I do root 6 times root 6? 6. So that's that's probably my preferred method, but whichever one works for you, you can do it that way. Okay, we've got one more example. So I've got 3 over 2 plus the square root of 5. And what we're going to do is we're going to rationalise this, so we need to get rid of the square root on the bottom. However, the difference is now we haven't just got a square root on the bottom. I've got 2 plus the square root. So we've got 2 things on the bottom and only one of them is the square root. What we do in this case is, again, we've got to times the top and the bottom by the same thing. And what we're going to do is we're going to times the bottom and the top by the conjugate of the bottom. And what I mean by the conjugate is whatever's on the bottom, I'm just going to change the sign. So if that's 2 plus root 5, I'm going to change it to 2 minus root 5. Okay, so then we've got this bracket on top. So 3 times 2 is going to be 6. Minus 3 times root 5 is going to be 3 root 5. So 6 minus 3 root 5 on the top. And the bottom, this is where it gets a little bit trickier. So 2 times 2 is 4. So positive root 5 times by negative. So positive times negative means it's going to be minus. Root 5 times root 5, which we know is going to be 5. Or root 25, same thing. Then the bottom here I've got root 5 times 2, so that's going to be plus 2 root 5. And I've got 2 times minus root 5, so that's going to be minus 2 root 5. And just like what happened in one of the first questions, 2 root 5 and then minus 2 root 5 is going to cancel out. So I've got 6 plus 3 root 5 on the top. And on the bottom I've got minus 1. And sorry, that was a minus, wasn't it there? Sorry. Now anything divided by 1 is just itself. But anything divided by minus 1, what happens is that the signs all change. So 6 divided by minus 1 is going to be minus 6. Minus 3 root 5 divided by minus 1 is going to be plus 3 root 5. So the answer is minus 6 plus 3 root 5, or if you wanted to write it the other way around so you don't have a negative first, you can say 3 root 5 minus 6. Okay, that's everything you need to know to give the second one a go. So good luck with the second sheet.